Alright, I've actually got a couple different models that I want to show you today just because I couldn't decide which one I was going to use. This is my first one, and part of my circles I drew them really quick outside. Now, this is the Candy Atom model, and we've used this in the 7th grade classroom that I'm student teaching in. We did this a couple weeks ago. And the kids really loved it. Obviously because it involves candy and and they get to choose. So what we had them do was they chose which atom they wanted to model. They could do a couple different ones, but they choose one. So let's say I'm gonna choose boron up here, and boron has an atomic number of 5. Yay! And so since the atomic number means that there's 5 protons, and protons are the biggest part of the atom, the biggest particle inside the atom, I chose to represent them with marshmallows because they're the biggest ones. They take up the most. They take up the most mass of the atom, and so they go inside the nucleus. And I'd put that in here, and then my M&Ms represent the neutrons, and so there's 5 neutrons. I'll put them around randomly. 5 neutrons, 5 protons inside the nucleus, and because they're small, they're the smallest candy I've got, 5 red hots for the electrons, and they'll go around here. And they can even, hey, so the first valence electron, or the first electron shell can only hold 2 electrons, so you would check to make sure that they only had 2 electrons in the first shell, and the rest of them will go on the outside shell. And then you can even, you'll walk around and check their work and make sure their electrons are in the right place, they have the right number of electrons, number of protons, number of neutrons. And then you can have the kids look at each other's atoms and try to guess what the atoms are based on the numbers. You know, if it had 6 protons, 6 neutrons, and 6 electrons, then they could guess that it's carbon by looking at the periodic table. Okay, and the second model that I wanted to show you was actually a project that I worked on this summer. I saw one of these board games. It was an atomic model board game online, and it was on sale for like $150, which I can't afford. So I was like, I'll make my own. And so I made my own, and the way that I would play it is I would roll a die. Let's see what I got. 5. Oh no, another boron. Okay, so it's a boron, and I'm going to choose blue for my protons. Okay, and I've got these little like craft gems, and so I put protons in the nucleus. White's going to be my neutrons. Oops, I only got 4 protons, so. Oh, yep, and one of these. Okay, so 5 protons, 5 neutrons, and then the orange is going to be my electrons. And I'll put those around the shells. So the first shell only has 1 and 2, and the next can go around like this. And you can even play it where like teams try to guess what the atom is based on the numbers on the board, or you can play against a partner to try to guess what the atom is. But the only issue that I have with these pieces that I chose is that they are all the same size, so you don't get that size differentiation. Like, you know, we try to teach them that electrons are much smaller than protons and neutrons, and they're swirling around at a really high speed, while the protons and neutrons are just kind of hanging out in the middle, and they take up a lot more of the mass. But that's the only thing that I have an issue with is there's no size difference between these two pieces. They're about the same. But if you let them use candy, you know, the red hots are much smaller, so they're a better representation of electrons. And then you can get big, fluffy protons and medium-sized neutrons. Okay, and one more thing that I happened to find at the school I'm student teaching at. There's this cool kit that I found in the back of the science closet. It's from 1984, but it's a step up from modeling the atom. It's modeling like molecules and compounds. And it comes with a bunch of different sized like beads things, and then these stems would be different kinds of bonds. I guess there could be, I think the large one represents double bonds, and these represent single bonds. I'm not sure, I'll have to read that manual to make sure exactly what each bond represents. But I went ahead and made what I would consider a water molecule, because it's got a bigger oxygen molecule, would be the red molecule, two bonds between two smaller hydrogen molecules, H2O. Anyway, so those are my versions of different models that you could use in a classroom. This board really wasn't hard to make. It's just a piece of wood that I drew on, really. Alright, well, have a good day. I hope this was helpful. Thanks.